Factoring by grouping can be done when there are 4 terms. So this is the type of factoring done when there are 4 terms. And often, not always, but often, the highest term is cubed. So often it's an x cubed type of polynomial. So first I'm going to leave a couple lines. We'll do an example, and as we do the example, then I'll kind of give some steps of how to factor by grouping. So we're going to do 3x cubed plus 21x squared plus 5x plus 35. So in this one, I have 4 terms. 1, 2, 3, 4 terms. It's x cubed. So how we do this is first we're going to kind of group the first 2 terms together and the second 2 terms together. So just out of the first 2, I'm going to factor out the greatest common factor. So they both have 3 that goes into it, and they both have at the most x squared. And then I'll start my parenthesis. So if I take 3x squared out of 3x cubed, I'm left with x. Plus, take 3 out of 21, I'm left with 7. X squared out of x squared, no x's, so just I'm left with x plus 7. And I can go back and kind of distribute to check. 3x times x is 3x cubed. Sorry, 3x squared times x is 3x cubed. 3x squared times 7 is 21x squared. Now out of the second 2, these have a 5 in common. So if I factor out 5, I'll be left with x plus 7. So now if I look at this as this 3x squared times x plus 7, that is one big term because these things are multiplied together. And 5 times x plus 7, this is one big term. So if I look at what do these big terms that I have those green braces under, what do these have in common? They have an x plus 7 in common. So if I factor x plus 7 out of those big terms, I'd be left with 3x squared and then a plus 5. Okay, so this is going to be my answer. Let's check it. So let's check it out by foiling. So I'm going to have x times 3x squared is 3x cubed. Outer is a plus 5x. Inner plus 21x squared. And then last plus 35. So if I look at my original problem, it's all the same terms. It's a little out of order, the middle 2 terms, but it's all there. It's the same polynomial. So I know I got the right answer. Okay, so let's go back to that space we left and kind of write out some steps of how we factor with these ones. So step 1 was to factor the first 2 terms. Factor the first 2 terms and second 2 terms. And then after that, step 2 is factor the common binomial out of each big term, like what I had with the braces underneath. So my answer basically, I have the common binomial, the thing they have in common first, binomial, and then in my second set of parentheses, it's like I have the leftovers. In this case, it was 3x squared and the plus 5 left over in front. So I always then, when I do this grouping, I'm always left with 2 binomials, so that when I FOIL it out, I get those 4 terms. Okay, let's do one more. So if I have x cubed plus 6x squared plus x plus 6. So split it down the middle, just out of the first 2. I'll have x squared in common. And I'm left with x plus 6. Now the second two, well, they don't have anything I can factor out, but it already matches up x plus 6. So if I have to put something there, what times x plus 6 gets me x plus 6? It's a 1. So my answer is x plus 6 times x squared plus 1 are the leftovers that I have out front. Again, FOIL that out, check it out. X times x squared is x cubed. X times 1 is x. 6 times x squared, 6x squared. 6 times 1 is 6. So I was able to factor it. Okay, one more actually. So the next one, x squared plus 4xy minus 3x minus 12y. So split it down the middle. So out of the first two, we have an x in common. So I'm left with x plus 4y. Now in the next two, I have a 3 in common, but also I'm kind of looking ahead at the signs. In the parentheses, I want to have the same thing. I want to have x plus 4y. So in order to do this, I'm going to have to factor out a negative 3. So negative 3x, negative 12y. So, but now that common binomial matches up. So my one binomial is x plus 4y. The other one is the stuff out front, x minus 3. Okay, so I get my two binomials. I could FOIL it out to check it, but that should match up to the original problem.